This lesson is for pointing out how to underline with a purpose and to think about your work. We're having an issue in class of students underlining and annotating like they're supposed to, but they're doing it just to show the lines in the paper. They're not really thinking while they're underlining and annotating. There's no purpose behind it. When there's no purpose behind it, it's kind of lacking the reason of why we are annotating, and it's getting lost. So then it's really, there's no point to it. So I'm going to underline and annotate here and kind of show you what I'm talking about and think through this problem. It says, Jack has 3,459 chickens and Jill has 123 chickens. I know that when I have two amounts combined, I'm going to be adding. So I know that Jack has 3,459, and I'm going to write that above Jack's name and circle Jack's name. And Jill has 123. So I know right now my quantities for Jack and Jill's chickens. How many chickens do Jack and Jill have? So I'm looking for how many chickens do Jack and Jill have, which is my total. So I just annotated the question. What I've done is I've thought about what the words are telling me, and I've kind of set up my problem. Now, let's go and read all the answer choices. A, the answer would be even because you're adding an even number to another even number. Okay, so wait a minute. I have the answer here. I don't have an answer here. But this is not really about the answer. It's about the odd and even number properties. So first, let's see if I'm adding an even number to another even number. Well, 9 is an odd number, and 3 is an odd number. So I don't even have to worry about the answer here because these both are even numbers adding, so I know A is not right. Let's go to B. The answer would be odd because you're adding an odd number to an odd number. So I am adding odd to odd, so that checks and that checks, but let's see what the answer would be. Would it be odd or would it be even? Now, I have to remember my addition properties, excuse me. Odd plus odd equals what? Now, if I can't remember, there's an easy way to check it. I can find two odd numbers that are smaller and add them together. 1 plus 3 are both odd numbers, and that equals 4, which is an even number. So obviously, it's not going to always equal odd. So I know that is wrong, which makes B wrong. The answer would be even because you're adding an odd to an odd. Well, I am adding an odd to an odd, and I did say odd plus odd up here did equal even, so I'm thinking C is my right answer, but I want to go to D to make sure there's not a better answer there. The answer would be odd because you're adding an even number to an even number. Well, I'm not doing those things. That is not correct, so I have proven without a shadow of my doubt the answer is C. That is what annotation should be. Kids should be thinking in their heads this way to be able to break down the problem so they can easily understand it. It's not happening as much as we would like for them to. Now, let's go look at some other ways of annotating when there's not words and they're just numbers. Here's a problem that was on the test. Okay, we're missing the first number, which means we're going to have to be working backwards. So we're going to go ahead and do this. Now, the kids are going to first look at this, and this is exactly what most kids did, and they're going to say, oh, the answer is 500. How do I know? Well, I mean, if you look at it, it's 325, 350, 375, 500. They totally did it so fast, they did not see that 400. So there was really no annotation all for here. They grabbed the answer and said 500. Some kids actually did show annotation, and they did either plus 50 or wrote plus 25 in between each of these numbers, which was not the case. So in other words, they just kept writing it, and they did not really... They showed the annotation to make me happy is what they did. They did plus 50, and they really didn't check to see that they were all plus 50. So how should students have shown work here? Let's look at that. All right, because we're missing the beginning number, we're going to have to work backwards. So we're going to have to go from 350 to 325. We're going to draw the arrows. And we're going to notice from 350 to 325, we're decreasing. So we're going to be able to subtract, or we can divide. I always put the two operations that can show a smaller number when I'm decreasing. Well, 350 divided by 1 is 350. 350 divided by 2 is going to be a lot less than 325, so I'm already taking that out of my mind. It's no longer division, but I do always try it in case it might be. So what would I have to subtract from 350 to get to 325? I can do this in my head without having to show it on the side, but it's minus 25. Now, I'm going to draw my arrow from 400 to 350. And I'm going to test this minus 25. Is 400 minus 25 gonna equal 350? It does not. That would equal 375. So my rule is not minus 25. It has to be something more complex. So how do I go from 400 to 350? Well, I know I'm decreasing. So that means I can subtract or divide. Division is not going to work because the answer 400 divided by 2 is 200. 400 divided by 1 is 100. That's not going to work. So I'm going to have to subtract. Well, I know right now that it's going to be minus 50. So I have minus 25 minus 50. I wonder if my next one is going to be minus 25 again, and if I'm just going to have a repeating pattern with two numbers. Let's go. Is 400 minus 25 475? I'm sorry, I said that backwards. Is 475 minus 25 400? No. Is 475 minus 50 400? No, it's not. It's neither one of those. It's actually minus 75. So as you can tell, we are now growing. This is a growing pattern. And each time we're going to subtract 100 less or 100 more, depending on which way you're looking. So to go from 475, what would be here? It would be minus 100 because it would be 25 more than last time, which makes my answer 575, not 500. That is using thinking with the annotation, not just doing it to put work on the paper to make, teachers happy. It's doing it for a purpose, and that's to get the right answer. Let's look at another example. Okay, here we have 4, 8, 7, 14, 13. This is what the students did. They said 4 plus 8 is plus 4. 8 plus 7, oh, that's not plus 4, that's minus 1. Okay, so I know my pattern is plus 4, minus 1. Plus 4, which would be 17. There's my answer. So what they did is they checked the first couple numbers, said, yep, I got it. It's plus 4 minus 1, and kept moving. That actually is not the pattern. So let's see how you would solve this correctly. The correct way to do this is to say 4 to 8 would be either plus 4 or times 2, because there's two ways to make numbers increase. We don't know which one of those works. To go from 8 to 7, plus 4 is not going to work. Neither is times 2. So now we have to look that it's decreasing. So minus or divide. Well, you can't divide 8 by anything and get 7, so I'm crossing that out. But you can subtract 1. Now I have plus 4 times 2 and minus 1 as three possibilities, excuse me. Let's go see which of those three works. Okay, 7 increased 14. Plus 4 is not going to work. I cannot say 7 plus 4 is 14. 7 times 2 does work. Minus 1 does not work. So let me keep going. 14 to 13 is a decreasing, and it is minus 1. So I can cross out my plus 4. I know that it's no longer there. And I have times 2 minus 1 times 2 minus 1. So my next part of the pattern is going to be times 2. Well, 13 times 2 is not a basic fact, but I know that I can repeatedly add from 3rd grade to get the same answer. 3 plus 3 is 6. 1 plus 1 is 2. My answer is 26. That is how the student should have solved. So again, our issues are not thinking through the problem, trying to quickly grab the answer, and not slowing enough to show the work that I know that they know how to do. They're doing it in class. I know they can do it. So please help me enforce this at home. I'd appreciate it, and I'm hoping to see lots of improvements on test grades. Thanks.